Today is question and answer and revision, okay? On whatever question you all want me to do, I will do it. Okay, but before we go there, there's this problem that we have not finished yet. Okay, so this is the one. And this is the problem that we had on Friday. And I realized that I made a mistake over here. If you all could correct it, over here should be plus, okay, and this should be minus, okay. I've posted on Avenue to Learn on week. If you go to Avenue to Learn now, okay, and let me show you what I mean. If you go to Avenue to Learn now, okay, and I posted on lecture on week 13 how to reinitiate the solver. Okay, so watch it, okay, to see how you can solve this equation, okay, this equation over here using the solver, okay, and it's very similar like what we did in buckling, but there's an extra step that I want you to watch, okay. So let me bring this equation across first. Okay, this entire equation. Let me complete this equation first. So by using the solver, we know that this value is equal to 0.75057 inches. Okay, and this is by using the solver. Okay, so if we were to recall, right, this is based on Tresca criteria, and this is what our or how our 3D finite, not finite element, Mohr circle look like. Okay, so the next thing that we have to, so after we found this, right, the next thing we have to check, we have to ensure that stress max, right, is less than positive 100 times 10 to the power 3 psi. And we also have to check that our stress mean is greater than minus 100 times 10 to the power 3 psi. Okay. So we know based on our Mohr circle, right? We know that our stress mean is not equal to 0. Okay, we are aware of, we are conscious of that. So when stress mean is not equal to 0, if we go back to our lecture, and this is the set of formula that we're going to apply now. Okay, so for this case, right, as you can see over here, stress mean is equal to 0. So we're going to use this set of formula to determine our stress max and our stress mean. Okay, so we're going to use this formula, all right, to determine our stress max and stress mean. So we have already discovered what our or our C value is, which is 0.75057. Then if we were to, I'm going to take this, okay, element. This is our element. Okay. And it is slightly different because we have stress Z. Okay, so let me change this formula over here. Okay, we change this formula over here. So this is our stress Z, stress Z, stress Z, and this is Z. Okay. And we know that normal stress Z is equal to 0. And we have done our expression to find our stress X. Okay, so we go over here, right? We know that stress X, right? And this is our formula for stress X. And we're dealing with element I. Right? I down there means element I. So we found that element I where it's likely to fail. Right. So now we're going to substitute. Okay. We're going to let this equal to minus 2500 minus by, so we just call it, okay, using the solver, we just use 0.75 or 0.751. Right. Then minus by 72 divide by pi, and then 0.751. And then we're going to cube. So this will be equal to 2500 times by 0.751 plus by 72, 123 divided by shift pi divided by 0.751 power 3 is equal to 55 minus 55.519 times 10 to the power 3 psi. And then we also have our shear, right? So you go back to our formula. This is our formula for our shear. Right? So this will be equal to 55200 divided by pi 0.751 power 3. So 55200 divided by shift pi divided by 0.751 power 3 is equal to 41.483 times 10 to the power 3 psi. Right. So from here, we are going to first determine our stress max. Okay, so we're going to find stress max. I'm going to copy the formula over. Okay, we're going to determine stress max first. And I'm going to get this to value 41.483. And then the other value is minus 55.519. Right. So over here will be equal to minus 55.519 times 10 to the power 3 divided by 2. We know stress Z is equal to 0. And then plus square root the whole thing. And we have 55 point minus 55.519. That's 10 to the power 3 divided by 2, the whole thing squared. Plus by the shear of 41.483 times 10 to the power 3, the whole thing squared. And this will be equal to minus 55.519 divided by 2 minus 27.760 times 10 to the power 3. And this will be plus by 55.519 power 3 divided by 2 squared. plus by 41.483 power of 3 squared. And the whole thing square root will be equal to 49.914 times 10 to the power 3. Let me do it again. 55.519 power of 3 divided by 2 squared plus by 41.483 power of 3 squared. The whole thing square root 49.1. Okay. So the stress max will be equal to minus 27.760 power 3 plus by 49.914 power 3 is equal to 22.154 times 10 to the power 3 psi. Okay. Which is less than positive 100 times 10 to the power 3 psi. So this is okay. You will not fail. Okay. Then the next one, we are going to determine stress mean. So stress mean is just by doing 27.760 and then we minus by 49.914. Okay. Why is that? If you look at the previous page, okay, so everything, the terms are the same. The only difference is one's a plus, the other one's a minus. Okay. So from here, this will be equal to 27.60 plus by 49.914, okay, minus 77.674 times 10 to the power 3 psi, which is greater than minus 100 times 10 to the power 3 psi. Okay, so this is also okay, right? And so what we have done is, if you look at the 3D mole circle, right? We shown that this point over here is minus 77.807 KSI. And we shown this point to be equal to 22.193 KSI, right? And we base on the maximum shear, and this distance is equal to 50 times 10 to the power 3 psi. So we can say that the structure is safe. Okay, we can say the structure is safe. So let's say if there's a question to ask you to calculate the factor of safety. Okay, so you take the 100 times 10 to the power 3 and you divide by the bigger value, 77.674 times 10 to the power 3. Okay. This is absolute value, right? Why is that? Because why you can ignore the minus is because Tresca assume stress U in tension is also stress U in compression. So this is tensile. And then over the other side, you have your compression. Okay. So this will be equal to 100 power 3 divided by 10.674 power. So the safety of factor is 1.287. Okay. So there's a safety of factor that we can determine. So you can see this problem over here that we started on Friday, right? It has failure analysis, okay? And this is what is expected of you guys in your exam. You have to able to determine which element has a higher stress, okay? And then we put in then you have to also be able to analyze using 3D mole circle, and then followed by that form up expression, right? you have to find out whether is stress mean equal to 0. Like over here, you have to find whether stress mean is equal to 0 or not. If not, what are the formula that you can use? Okay, so there are two. For this case, stress mean is equal to 0. For this, the one below over here, stress mean is not equal to 0. So you can apply this formula.